Okay, so in today's video we're going to be talking specifically about eye tracking, being able to follow an object, specifically following like a pitched baseball or a volleyball or something that you need to track with your eyes and then be able to make contact with it. So we're going to use a baseball in this example, basically a right-handed pitcher pitching to a right-handed batter. So basically the ball is going to be traveling in the batter's visual field from his left to his right. Now in order to do that movement with the eyes, there's two main areas that are involved. It's going to be the left cerebellum and primarily the right parietal cortex. So the cerebellum is a part of the brain that deals with smooth muscle movement, control, helps with our balance. It also controls our eye movements as far as keeping them smooth, and it also controls all the little muscles that go along your spine. It gives you core stability. So when you need to basically focus on something that's coming out of your periphery or your field of vision, your eyes churn to look at that object. It's the signals that go to your eyes and the signals that go down to your muscles along your spine that keep you stable, so that when you turn your head and move your eyes, you don't fall over. So what we're looking at here is when we're trying to hit the ball, if the ball's traveling from left to right, the parietal lobe is pulling your eyes on the right towards your right. So the right parietal lobe is moving your eyes and pulling them to the right in order to help follow the ball. The left cerebellum is what keeps the movement nice and smooth. So if we have and these two areas are directly connected to each other. So if we have a breakdown in cerebellar function, what will happen is the eye movement won't be smooth, so you'll be following the ball, and all of a sudden the cerebellum will fatigue and you'll get a little jerk or a movement in the eye, and you'll lose focus on the ball for that split second. So now your reaction time to swing is a little bit off, and you'll either miss the ball entirely or you'll be able to not make good contact with the ball and make a good hit. Also, same thing dealing with the right parietal lobe. If it's not doing its job very well, it won't be as quick to pull the eye across, so your tracking will be a split second behind the ball. And once again, when you go to swing, you're going to be a split second behind, so instead of making good contact, you're going to fall the ball off, or you're going to hit a grounder or something that in baseball obviously you don't want to do. So what things we want to look at is look to see what can we do to help increase, if the person has a weak cerebellum, what can we do to help increase that cerebellar function, and also if they have a weak parietal lobe, what can we do to help that get stimulated before they actually walk even into the batter's box. So in this situation, the left cerebellum is controlling primarily information from the muscles on the left side of your body. So we can have batters stand before they get into the batter box, balance on their left leg, which can be a stimulation to the left cerebellum. They can get in, they can do some squeezing exercises with the left hand. We can actually even have them do eye movements where we have them look up and to the left and down and to the right. That is a left cerebellar action or left cerebellar function. And by doing those couple of things, we can activate that cerebellum and bring it closer to threshold so that it reacts faster. And that way when you actually try to track the ball, you can actually track it faster, be able to lock onto it, and be able to make good contact with the ball. This is just go for baseball. This is for anything where we have to track or follow an object going from left to right, right to left. In this case, going from left to right, it's left cerebellum, right parietal lobe. If it's coming from right to left, it's right cerebellum, left parietal lobe. And by doing an evaluation on these different areas of the brain, we can find out where the weaknesses are and have these athletes doing specific exercises to stimulate those areas in their brain that then once they're working at an optimal level or better than what they were previously, then you get muscle response times to kick in faster. So ultimately it's the brain that's controlling the muscles and their tone and how fast they can respond to commands that we try to give them. And so if we can increase reflex time, obviously we can then increase speed, which when it comes to athletics is an integral part of being able to not only lock onto objects but track them and be able to hit them as well. Or in cases like in hockey, being able to track a hockey puck as it's coming and be able to react and catch it. In volleyball, to be able to see a spike coming in and be able to get under and dig that spike. The list goes on and on as far as what things can be affected in a positive way by making sure that this neurological loop is working at its optimal for each individual athlete.